2015 problem number 6. You are first asked to find an equation for a tangent line. When I prep for equation of tangent lines, I prep it with y minus find the number equals find the slope times x minus figure out what number. And then I know that these 3 blanks need to be filled with specific numbers. And we've already got those 2. And feel free to just write that as +1. That's perfectly fine. So then all I need to find is the slope dy dx at that point. Now they gave me a formula for dy dx, so I'm just simply going to plug in the x and y coordinate. The y coordinate is 1. The x coordinate is -1. So the slope is 1/4. When they ask you to write an equation of a tangent line, this is sufficient as an answer. You do not have to isolate the y. An equation of a line doesn't actually have to be solved for y. And that's part A. Moving on to part B. And I'm going to erase stuff and get it out of the way. And now part B. We want to find the coordinates of all the points on the curve at which the tangent line is vertical. My tangent line is going to be vertical if my denominator is equal to 0 and my numerator is not equal to 0. So 3y squared minus x equals 0, and y does not equal 0. Now, sometimes when they grade the exams, not having this part, you get away with it if you don't have it. But other times when they grade the exams, that is expected. It is best if, when you're dealing with things like vertical tangent lines, where you know the denominator needs to be 0, but the numerator technically needs to not be 0, you should write that down. All right, now we've got to figure out what to do from there. We want to realize that we have this equation, and we have now this equation. So we have 2 equations with 2 unknowns. Woo! So it's just solving a system, and you're looking for what's my easiest way out. You should notice there's only a singleton x in both of those equations. So our easiest way out is to isolate the x in one and plug it into the other. So if x is equal to 3y squared, I can then bring this in, and I have y cubed minus bleh y equals 2, and the bleh is 3y squared. And if y cubed is equal to -1, then y has to be equal to 1. I want to make sure that I answer the question, so I want to read it again. Find the coordinates of all the points. I've got a y coordinate, I need the x coordinate. I can turn to one of my equations and plug in y equals -1. And then I can say that there is a vertical tangent line at 3, -1. And let's double check. We did meet the requirements of y not being equal to 0. And this was the only solution that we could get out of that equation. So that's it. And that's done. Was that fun? Maybe? All right, part D. I'm going to erase all of this so that I can show work near part D. I want to find the second derivative of y with respect to x at a particular point. That means I need to take my dy dx and take its derivative with respect to x. So I'm going to write this out in proper notation. The second derivative is equal to the d dx of y over 3y squared minus x. And I wanted to make sure to write out that d dx to clarify to you that you have to be taking the derivative with respect to x. Every time you go through a derivative that contains the y, you have to chain rule what you are working with. So I see a quotient rule coming on, so it's time to get loaded on math. Math. Loady high. Low d high. Now for d high, I'm taking the derivative with respect to x. So the derivative of y with respect to x is dy dx. Minus high d low. As I go through d low, I start before the subtraction with 3y squared, but I realize y is an x. So I look at it as y is a baby function. So I really have 3 blah squared. The derivative of the mommy 3 blah squared is 6 blah. The baby is y, so I shove it in and I multiply by its derivative with respect to the x variable. Then after that subtraction, I have just an x. Derivative with respect to x is 1. Square the bottom, and away we go. So now I still need to plug in this point. Everywhere I see an x, I'm going to put a negative 1. Everywhere I see a y, I'm going to put a 1. And then for every dy dx, I'm going to put in what I had found in part 1. In part 1, we found the slope at that point to be 1/4. So I will replace each of those dy dx's with 1/4. My advice is plug them in and leave it. Don't do your arithmetic. So I'm just going to write out a final step of doing that. So if y is 1, minus negative 1, and once I have plugged the numbers in, however I have it at that point, just hands off and done.